The battery you are using right now, in your phone, your laptop, your car, is about to become obsolete. Not in 20 years. Not in 10 years. Now, 5 battery breakthroughs have emerged in 2026 that are so significant, so game-changing, that engineers are calling this the most important moment in energy science since the invention of the lithium-ion cell in 1991. We are talking about batteries that charge in 5 minutes. Batteries that never catch fire. Batteries that last the entire lifetime of your car. And one breakthrough, backed by Elon Musk himself, that could make today's best batteries look like AA cells from a dollar store. Welcome to Hi-Futuretech. These are the top 5 battery breakthroughs that will change everything in 2026. For 35 years, the lithium-ion battery has been the foundation of every portable device on Earth. Your iPhone, your Tesla, your laptop, all running on technology invented in 1991. And for 35 years, the fundamental limitations stayed the same: fire risk, slow charging, limited range, and degradation over time. In 2026, all 5 of those limitations are being solved simultaneously. And the 5 breakthroughs doing it are going to restructure the entire energy and transportation industry. Let's count them down, starting with number 5. At number 5, the breakthrough that is about to make electric vehicles affordable for every American family: sodium-ion batteries. Here is the problem with lithium. The world does not have enough of it. Lithium is rare, expensive to mine, and 80% of the world's supply is controlled by just 3 countries. That is why EV batteries cost so much, and why truly affordable electric cars have been impossible to build. Sodium changes everything. Sodium is literally salt. It is the 4th most abundant element on Earth. It costs almost nothing. And in 2026, CATL, the world's largest battery manufacturer, has begun mass production of sodium-ion battery cells for the first time in history. The numbers are extraordinary. CATL sodium-ion cells have achieved energy density of 160 watt-hours per kilogram, now approaching lithium-ion performance. Their Naxtra sodium battery has passed 10,000 charge cycles in testing, meaning it lasts the lifetime of the vehicle. And the cost? Sodium-ion batteries cost 30 to 40% less to produce than lithium-ion. That is the difference between a $40,000 EV and a $25,000 EV. Sodium-ion batteries are the technology that finally puts an electric car in every American driveway. Number 4, and this one is already inside products that Americans are buying right now: silicon anode batteries. In a standard lithium-ion battery, the anode, the negative electrode, is made from graphite. Graphite works, but it has a fundamental limitation. It can only hold so much lithium per unit of weight. Silicon can hold 10 times more lithium than graphite. 10 times. That means a silicon anode battery has the potential to store 10 times more energy in the same space and weight. The problem that blocked silicon for 20 years was expansion. Silicon swells up to 300% of its size during charging and then shrinks back, cracking and destroying the battery after just a few cycles. Engineers called it the silicon breathing problem. In 2026, that problem has been solved. Companies like Amprius Technologies and Samsung SDI have developed nanostructured silicon. Silicon engineered at the atomic level into tiny pillars and wires that flex instead of crack. Amprius has already delivered silicon anode cells achieving 450 watt-hours per kilogram, nearly double the best lithium-ion cells available today. Their cells are currently being used in high-altitude solar aircraft that need to stay airborne for weeks at a time. And Samsung is already scaling silicon anode production for the next generation of Galaxy devices and EV batteries launching in late 2026. Number 3, the breakthrough that solves the one problem that has scared Americans away from electric vehicles more than anything else: battery fires. Every lithium-ion battery on the road uses a liquid electrolyte to carry charge between terminals. That liquid is flammable. When damaged or overheated, it ignites in a reaction called thermal runaway that burns at over 1,000 degrees Fahrenheit, hot enough to melt aluminum, and cannot be extinguished with water. Solid-state batteries replace that liquid with a solid ceramic or sulfide material. Solid ceramic does not burn. You can puncture it. You can crush it. You can heat it. It will not catch fire. Thermal runaway becomes physically impossible. But fire safety is only the beginning of what solid-state unlocks. Solid electrolytes are more stable, allowing the use of lithium metal anodes instead of graphite, pushing energy density to levels that deliver 700 to 1,000 kilometer range in a single charge. And solid electrolytes handle higher charge currents without degrading, enabling full charges in 10 to 15 minutes. Toyota has committed $13.6 billion to solid-state production and has announced their first solid-state vehicle for 2027 to 2028. QuantumScape, backed by Volkswagen and Bill Gates, has validated cells surviving over 1,000 charge cycles with no degradation in real-world testing. Solid Power, partnered with BMW and Ford, has begun pilot production runs in 2026. This is not the future of batteries. It is the present, and it is just getting started. Number 2. The breakthrough that is rewriting the absolute limits of what a battery can do. Lithium-sulfur batteries. Every energy storage technology has a theoretical maximum, a ceiling that physics sets and engineering tries to reach. For lithium-ion, that theoretical maximum is around 400 watt-hours per kilogram. The best cells today reach about 300. Lithium-sulfur's theoretical maximum is 2,600 watt-hours per kilogram. That is 6 to 8 times more energy dense than anything on the market today. Sulfur is also the 10th most abundant element in the universe. It is a byproduct of oil refining, meaning there is essentially an infinite supply already being produced as industrial waste. The raw material cost of lithium-sulfur batteries approaches zero. The breakthrough that unlocked lithium-sulfur in 2026 came from solving the polysulfide shuttle problem, a chemical reaction that caused sulfur to dissolve into the electrolyte and destroy the battery after just a few cycles. Researchers at Drexel University and the team at Lighten Inc., a San Jose startup backed by the U.S. Department of Energy, have developed new cathode structures that trap polysulfides in place, extending cycle life to commercially viable levels for the first time. Lighten's lithium-sulfur cells are already being tested by the U.S. military in drones and communications equipment. Their cells weigh 40% less than equivalent lithium-ion cells while delivering the same energy, a breakthrough for any application where weight is critical. Aviation, defense, and space applications are already in contract discussions for 2026 to 2027 delivery. When lithium-sulfur reaches consumer scale, an electric car battery that currently weighs 1,000 pounds could weigh 250 pounds and deliver 4 times the range. That is the trajectory this technology is on. And number 1. The breakthrough that every energy scientist, every automaker, and every technology investor on Earth is watching right now. Tesla's aluminum-ion battery. In early 2025, Tesla quietly filed a series of patents for a new battery chemistry based on aluminum ions instead of lithium ions. And the theoretical specifications attached to those patents stopped the entire battery research community in its tracks. Here is why aluminum changes everything. Aluminum is the most abundant metal in the Earth's crust. It costs a fraction of a cent per gram. It is found on every continent. There are no supply chain issues, no geopolitical dependencies, no rare earth mining problems. Aluminum is everywhere. But what aluminum can do inside a battery is what makes this the #1 breakthrough of 2026. Stanford University demonstrated an aluminum-ion prototype that charged from completely dead to completely full in 60 seconds. 60 seconds, not minutes, seconds. Tesla's engineering team has since moved beyond Stanford's prototype and filed patents describing aluminum-ion cells with energy density approaching 400 watt-hours per kilogram, a charge time under 5 minutes at commercial scale, a projected cycle life of over 10,000 full charges, roughly 30 years of daily use, and a material cost 90% lower than lithium-ion. If these specifications are achieved in production, and Tesla has not released production vehicles yet, this single breakthrough obsoletes every other battery technology on this list, including solid-state, including lithium-sulfur. Tesla has allocated a dedicated section of their Nevada Gigafactory to aluminum-ion pilot production. Industry analysts expect a formal announcement and prototype vehicle demonstration before the end of 2026. When that announcement comes, and it is coming, it will be the single most important moment in the history of energy storage. And Hi-Futuretech will be here, covering it the moment it breaks. Sodium-ion, silicon anode, solid-state, Lithium-Sulfur, Aluminum-Ion. 5 breakthroughs. 5 solutions to problems that have held back clean energy for decades. And all 5 arriving in the same year, 2026. The battery that powers your world is about to be replaced. Not gradually, not eventually, now. And when it happens, the ripple effects will touch every industry, every household, and every vehicle on Earth. Subscribe to Hi-Futuretech so you never miss a moment of this revolution. And comment below, which of these 5 breakthroughs excites you the most? The answer might surprise you. See you in the next one.